Here we are at the beginning of another series brought to you by the Science of Flight. In this series, we're going to be learning Arduino together. We'll start out with some of the basics and then start looking at using Arduino for flight controls and flight systems. In this first video, we're going to look at why you, as an aerospace engineer, should learn Arduino. Let's get to it. In this video, we're going to start with a brief introduction onto what an Arduino is. We're going to look at a few flight systems of an aircraft for which you might want to try and use an Arduino. And then we'll finish up the video with a quick discussion on why you might choose Arduino instead of another available option that you have. Now, if you're an aerospace engineer, or one day hope to be an aerospace engineer, go ahead and subscribe to the channel. This channel is dedicated to helping you as an aerospace engineer take your skills to the next level.
So what is an Arduino? The simple answer is that an Arduino is a microcontroller. It's a little bit different than, say, a Raspberry Pi, which would be a mini computer that has an operating system. As a microcontroller, it means that I can control objects. I can send out commands to different objects like a motor to control it. It also means that I can read in sensors. So if I have a temperature sensor or a light sensor, I could read the values from the sensors into this controller, and then I can change how I'm commanding my different objects based on what I'm reading off my sensors. Now, you're also able to attach different user input devices, so switches or knobs, so that you can alter the way that the controller, the microcontroller, behaves. Since this is a basic electronic system, you're going to have your power that you need to deliver to the Arduino. And then since this is a microcontroller without an operating system, you're going to need some way to program it. So that would be like a USB connection. These are all basic components of an electronic system. So what makes Arduino Arduino? Arduino is becoming more than just a microcontroller. It's kind of becoming a platform on which to build electronic systems. And I say a platform because it is open source, which means there is a user community built around Arduino. And there's plenty of software companies and hardware companies out there developing software for Arduinos or developing different boards or sensors or things that work with Arduinos. So it's kind of more than just the microcontroller. It's more of a community of users, a bunch of different types of controller boards, different sensors that work with it. And so it's really all of these things combined. It's hardware, it's software, it's people.
Let's go over a quick example of a robot that I built in a Robotics 101 course, and just kind of point out the different pieces of the electronic system. This little robot is named Otto. You can see it's a two-legged robot. It's actually a dancing robot. I'm going to go ahead and put a video of him dancing up in the top corner for you to watch as we kind of go through what makes Otto Otto. So the first thing about this robot is that he has two legs. Each of these legs has two motors associated with it. So as you can see here, I've got one motor that allows me to twist. Then I've got another motor that allows me to actuate the foot. So that's two separate motors for this individual leg. And then of course I've got two on the other leg as well. So when talking about electronic systems, these motors would be something that I would need to command and control. An example of something you might command and control on an aircraft would be the control surfaces. Now, another basic part of an electronic system would be sensors. Now, these two eyes of the robot are actually sensors. They're ultrasonic sensors, so it sends out sound and it receives sound, and it's able to measure the distance to an object up to a certain extent, right? There's a limit in terms of how far it can measure, but those are actually sensors. So an example of a sensor that you would have on an aircraft would be the pitot tube, right? You're trying to determine how high you're flying based on the pressure of the atmosphere. You might have some other sensors like GPS sensors to determine where you are. You might have an attitude sensor or a angle of attack sensor. So with a sensor in an electronic system, you need to read the value off the sensor. You might need to convert it to the right units that you're working with. You might then need to filter it, or you might pass it to your controller to be able to change the logic of the system, or how your aircraft behaves based on what the sensor sees. In the previous slide, we talked about how electronic systems have a power supply, and oftentimes it has some sort of port for you to connect to be able to program it or debug it, to see what's going on with the actual brains of the object. And Auto has those as well. As you can see here, we got a power supply. Where is it? We got a power supply and a little USB connector that we can connect to the computer and change the software running on Auto. Now, as you can see, this is a great example of why we prototype. So the design of this Auto robot, Auto is O-T-T-O, had this hole for the power supply in the wrong spot. So I had to actually kind of carve up a little bit to be able to get that to fit inside this 3D printed head. So at this point, obviously it means you would probably redesign the head and then reprint it out if you're working on a prototype. Now, when it comes to aircraft, there's several different ways that they obtain power. They could be running off battery. There was a solar plane that just happened recently, flew around the world on solar power. Sometimes they'll just pull power off of the shaft, the turbine shaft, in like a turbofan or a turboshaft engine. Sometimes you'll have APUs, alternate power units, where it's almost like a little turbofans running outside of the aircraft that's powering the systems. Acts kind of like a generator. So there's several different ways that you might power your aircraft. Now, another basic component of electronic systems that we talked about before is user inputs. Now, there is a user input on Auto. It's kind of hard to see. It's this blue thing right here. That's actually an on and off switch. So if you click it on, it'll start running through its program. If you click it off, it'll turn off the robot. That's an example of a user input. So the behavior of the robot changes based on how I modify or how I change the user input. So some user inputs on aircraft might be, if you're actually flying the plane yourself, might be the controls in the cockpit. If you're flying like a UAV, it would probably be the controller. Now that also adds some other challenges where you need to be able to connect the controller to the aircraft, which is why after we run through some of these kits, we're probably going to look at some of the connectivity available with Arduino, so that we can kind of look and see how we can prototype flight systems with Arduino. All right, so let's go ahead and open the robot up, decapitating him. So if you look inside, you will see a bunch of wires, right? This would be harnessing. That's always a fun job of an electronic system. Here's something that was inside that you didn't really get to see. It's a little buzzer, so it makes audible noises. This could be kind of a sensor. It could also be part of a kind of a warning system to the operator, or providing feedback to the operator of the state of the system. So you can kind of see in here, we got power supply with a couple batteries. With Arduinos, a lot of times you can hook up your own power to run off batteries, or like I showed you before, you can actually have it just run off of an outlet with a cord extending to it. Sometimes you're able to run it off of the USB power. So if you go ahead and if you look in here, you'll see that's one of the motors for the legs for twisting it. You can see buried in there that white piece is actually holding down the on-off button. So if I screwed out that piece, then I could pull the on-off button out. Something else to keep in mind when we have this opened up, you'll notice that the electronics are integrated oftentimes into the body of your system, right? You'll see that these servos are screwed into the body into the 3D print itself, or I'm screwing sensors down into it, or I've got a location where I can store a battery. So that's something to consider when we're doing some of these projects for aircraft, is that we might need to look at how we can mount motors or mount different sensors or user inputs or the actual electronics of the system. Now, as you can see, this robot is actually controlled by Arduino. You can see that there's this base shield underneath. There's a stack right here. There's a base shield at the bottom, and then there's this Arduino Nano up on top. So this Arduino Nano is actually the brains of the system, and it's doing everything we talked about on the last slide. It's sending out commands, it's reading inputs, it's reading sensors, it's listening for user inputs. It's also integrating the power and everything to the different pieces. Well, actually the shield down here is kind of doing some of that. This little shield down here is doing some of the power and stuff. But this is really kind of the brains that's running the robot. As in this series, as we're looking at Arduino, we're going to look to see how we can take this Arduino, right, the brain of the system, and incorporate it with sensors and motors and different user input devices to be able to build other things like quadcopters or UAVs or movable fins on a model rocket. So that's kind of the idea behind this series, is so that we can learn about these Arduino controllers and how to create different robotic devices out of them. These are all basic pieces of an electronic system. You see them in robots. You'll see them in aircraft as well. So as an aerospace engineer, it's good to start becoming familiar with some of these pieces and developing your skill, because if you're wanting to, say, build your own quadcopter, you're going to need to know how to deal with the power supply to it. You're going to need to know how to program it. You're going to need to know how to control the motors, how to read sensors. You're going to need to know how to mess with user inputs. So a lot of these basic components of an electronic systems that we're going to learn in these kits and in these tutorials in this series are really going to help prepare us for when we tackle a project like building our own quadcopter.
At this point of the video, you might be asking yourself, I'm an aerospace engineer, why do I need to know about electronic systems? Well, to put it simply, airplanes need electronic systems to fly. And there are many different types of electronic systems on an aircraft. For instance, you might have an electronic system controlling the control surfaces so that you are actually able to maneuver the aircraft. You could have propulsion systems where you need to control the speed of a propeller, the pitch of a propeller. You might need to control the valves that allow a certain amount of fuel into an engine. There will be flight controls, whether that is a human actually in the cockpit manipulating the controls, or a pilot standing on the ground manipulating a remote controller that sends commands to a remote aircraft. There are going to be some flight controls that need to take place. Now, something that goes hand in hand with flight controls would be a flight computer, right? That's where you put your control laws or your control algorithm for the aircraft. But flight computers can be more than just that. They could have different sensors as well, right? It might have GPS to figure out where you are, to do some guidance and navigation. It might have some inertial measurement unit to tell how the body is changing orientation during flight. It might even have some sensors to tell the computer how high you are, what altitude you're flying at based on the pressure in the air. With the fly-by-wire systems that we have nowadays, a computer is there in the loop interpreting the user input and converting it into commands. Airplanes have other actuation systems like deployable landing gear or wing deployment systems or fin deployment systems. And then, of course, there are other electronic systems that you might deal with as an aerospace engineer, particularly when you look at testing equipment. I have an image here of a wind tunnel. Now, there are going to be electronic systems controlling the wind in that tunnel, right? It's going to control the speed of the fan. It could also control some of the vanes. There might be some control of the mount so that you can change the orientation of the model to the incoming flow of air. And of course, it's going to have some sensor systems to pick up the forces and moments on the model due to the airflow around it. Now, these are just the first things that came to mind when thinking of what kind of electronic systems aircraft deal with. As you can see by these 6 types of subsystems on an aircraft, as an aerospace engineer wanting to build flying objects, you're going to need some electronic systems. Hopefully at this point it's becoming obvious as to why you might want to learn Arduino as an aerospace engineer. We know that Arduino is there to build electronic systems. We know that aircraft have electronic systems. And so naturally, Arduino becomes one of the potential solutions, right? The potential options we have when developing or building these electronic systems. So the question becomes, why Arduino? I'll go ahead and I will tell you the reason that I decided to learn Arduino. The reason I decided to learn Arduino is that Arduinos are good as a cheap, quick prototype solution. So while you're in the development phase of a new quadcopter or you're looking at adding movable fins onto a model rocket, Arduino can be a powerful tool to come up with a quick, cheap prototype system for these different projects. Now, of course, if you're starting your own company and you're wanting to learn how to make drones and sell them on the internet, Arduino may or may not be your final solution for your drone or your model rocket, right? You might decide to just go with Arduino because it's simple to just buy an Arduino and load your program onto it and hook up the wires and you're good to go. Or you may decide that after you've developed your prototype and you've proved out your design and you start moving towards production, maybe then you'll start looking at developing the printed circuit board that you would put in there in place of the Arduino. But during the development stage, Arduino could be a prototyping solution. Now, Arduino isn't the only solution, and I'll definitely in the future have other series here on YouTube where I decide to go out and explore and learn other options besides Arduino and ultimately evaluate them as well for different flight systems. The reason that I'm taking the time to learn Arduino and I guess make a YouTube series so that you can learn it with me is that I have some projects that I want to do in the near future. Oh man, I'd love to build a homemade quadcopter, or I'd love to do thrust vector control on a model rocket, or doing different fin control on a model rocket. I'd love to be able to build my own wind tunnel right in my own backyard. That's probably more a couple years out. And so this series is going to be dedicated to me learning Arduino and sharing the basics with you so that as we tackle those other projects in the near future, that we'll both be prepared for those projects.
Let's go ahead and talk a little bit about what the next couple videos in this series are going to be about. So since this is the basics part of the series where we're just learning Arduino from the very beginning, We're going to go ahead and start with an Arduino starter kit. I went ahead and I purchased one from Amazon. So we're going to be going and looking at this kit right here. It's got several tutorials, all designed to help us learn Arduino. So as you can see, I see a breadboard, I see some motors, I see some sensors and some LED lights. So I think it's got So in the next video, we're going to do an unboxing, and we can see all the components in this kit, and we're going to then start running through several tutorials to help us learn the very basics of Arduino. After that, I went ahead and I bought another kit that's all about sensors. I bought this off of Amazon as well. So after we finish the starter kit, we'll go ahead and we'll take a look at this sensor kit and start looking at how we can use Arduino with a lot of these sensors. After that, we'll probably look at maybe some of the other stuff that I don't have in these kits, maybe looking at some connectivity things, right? Connecting to Bluetooth or Wi-Fi, or maybe some other sensors as well, where we might look at what we need to do to turn an Arduino into a flight computer, or what we need to do to an Arduino to use it for some of the other flight systems, like controlling the control surfaces or deploying landing gear. With that being said, go ahead and click on the next video so that we can start with the unboxing of the Arduino starter kit.